Hello. Let us start the topic of normal distribution. Normal distribution is probably the most widely known and used of all the distributions. The reason for that is because many natural phenomena follows the normal distribution, like if you measure the diameter of the tree, or height of the people, or observe the IQ level of the people, then you would find that the variables follow the normal distribution. And it has got a lot of application in business, finance, and data analytics. Okay, so we will look into the normal distribution in detail, and we will study each and every property of the curve, and at the end of the session we would try to solve some examples, and we will also perform the Excel modeling of the normal distribution. Okay, so first let us see how does the curve look like. Okay, this is a normal distribution curve having mean mu and variance sigma square. Mu value is where most of the observations cluster around. Okay, and as we go away from mu, the frequencies or the number of observations gets decreased. Okay, now why to learn normal distribution? Because this I have explained earlier also, that many natural phenomena like heights, blood pressure, or IQ scores follow the normal distribution, and it has got the applications in business and industry. Okay, so now let us see the properties of normal distribution curve. Okay, so if you see the shape of the curve, you would observe that most of the observations cluster around the central peak, that is mu, as we have already seen. Okay, and the probabilities for values further away from the mean taper off equally in both directions. Okay, the nature of the curve is such that the extreme values in both tails of the distributions are very unlikely. What is the meaning of that? It means that the probability for extreme value is very less and the probability for the mid value is very high. Another property is it is bell shaped in nature. If you see the shape of bell, then you would find that it resembles the normal distribution curve. Now, our total area under normal distribution curve is 1. This is one of the properties of continuous curve. Okay. Now, since it is symmetrical in nature, thus 50% of the values lie to the left of the mean and 50% of the values lie to the right of the mean. Another property is normal distribution curve is symmetric about the mean. Okay. What does it mean? It means that the probability and area of the curve beyond mu plus x1 is equal to probability and area of the curve till mu minus x1. Okay, that is probability x is greater than mu plus x1 is equal to probability if x is less than mu minus x1. That is the probability of random variable greater than mu plus x1 is equal to probability of random variable less than mu minus x1. Okay, now since in case of continuous distribution the probability is nothing but the area of the curve, so a1 is equal to a2. Okay, now the mean, median, and mode of the normal distribution curve are same since it is symmetric in nature. Now let us see what happens when we keep the variance constant but vary the mean of the normal distribution curve. Okay, so in case of first curve, mean is 10 and variance is 18. In case of second, the mean is 16 while the variance is constant, that is 18, and in case of third curve, the mean is 24 and the variance is 18. Okay, so as we increase the mean of the curve shift towards the right. Remember, there is no difference in the spread of the curve among these three curves. Okay, the spread of the curve is constant since the spread is directly related to the variance of the curve. Okay, so since variance is kept constant, the spread of the curve is constant. Okay, while the curve is moving towards the right because we are increasing the mean of the distribution. Okay, Now, what would happen if the mean is kept constant but the variance are different? Okay. In case of first curve, the variance is 1. In case of second curve, the variance is 4. And in case of green one, the variance is 16. Okay. So, you can easily see that since the mean is constant, the curve is not shifting its position. Okay, the curve is not moving towards right or it's not moving towards the left. The curve is maintaining its position, but the spread of the curve is getting increased along with the reduction in peak of the curve. This is because of the reason that the variance of the curve is increased. So as we increase the variance of normal distribution, the spread of the curve would increase. Okay, and in order to maintain the same area, that is area is 1, in order to maintain the same area of the curve, the peak must reduce. Okay, so remember, as we increase the variance of the curve, its peak gets reduced and the spread of the curve gets increased. Okay, now let us see the probability density function of normal distribution. It is denoted by fx equals to 1 divided by sigma times root over 2 pi multiplied by e to power minus 1 by 2 times x minus mu divided by sigma whole square. Okay, where mu is the mean of the x and sigma is standard deviation of x. Okay, this equation might seem very complex to you, but you don't need to memorize it because almost all the researchers use the normal distribution table for the calculation of probability. Okay, we are not going to use this equation for the calculation of probability. This is just shown here for the reference purpose. Let us see about another very important property of normal distribution. Okay, here you can see the whole curve shaded into 3 portions, that is red, yellow and blue. So when x lies between mu minus sigma to mu plus sigma, the area of the curve is 68.27%. When x lies between mu minus 2 sigma to mu plus 2 sigma, the area of the curve is 95.45%. And when the range of x is mu minus 3 sigma to mu plus 3 sigma, the area of the curve is 99.73%. Okay, so this is nothing but the associated probability of the random variable. Okay, here I have mentioned the probabilities depending upon the range of random variable. Okay, now this property is important since it would help us in defining the confidence interval and in proposing the hypothesis test in our future classes, and we are going to use this property for problem solving approach too. Okay, thank you.